Assalamualaikum. My name is BINTI. My metric number is BF21403. So today I would like to talk about introduction for our project. This project is innovation from elderly bridge to newer design of the bridge with the addition of the trusses, changing for location of support reaction and load applied on the bridge or truss. So in order to provide passage over the obstacle, which is typically something that is otherwise difficult or impossible to cross the bridge, it is designed to span it without obstructing the path below. So the top and bottom part, which are two connected parts that make up the top and bottom of the truss, in order or in reaction to dynamic loads, the coupled elements may experience tension, compression, or occasionally both types of the stress. So for this project, the innovation for the older bridge is known as the Johannesburg and Pretoria. So the length of the bridge is nearly 10 meters long, which is very common for a bridge at rural areas such as Dengkil to Banting City. So this type of bridge usually could withstand or can afford to withstand high amount of load passing on top of it. So it has width of 3 meters wide, as most of a vehicle can pass through this bridge easily.
Hi and Assalamualaikum. My name is Nurul Syamina Afika binti Design. My number matric is BF2140372. And now I'm going to present about the layout and design of this project. So in this project, the Pratt Truss design has been selected as the proposed bridge in this project. So we have choose from the design of existing steel bridge, which is the 77-year-old railway bridge, which function is to carry the passenger from Johannesburg and Pretoria. The reason why we choose Pratt Truss as our design, it is because truss is a proper design to be built as a bridge because it has interconnecting triangle structure to support the huge load bearing capacity. Next, the Pratt Truss is also known as a cost-effective design, and it has a simple design than the other truss and easy to be constructed. Next, the internal member behavior is also easier to be addressed than the other design. In this project, we have made a bridge with some specification that has its function, which act as a bridge that connect from Dengkil to Banting City, as it was a main route for heavy transportation such as for 10 lorry. So the specification for the bridge is the span is 10 meter, the height of bridge is 3 meter, as the common limit under the bridge at the roadway in the semi-urban city is 2 to 3 meter. So in the manual calculation part, the young modulus E and the cross-section area A is assumed as constant.
Assalamualaikum and hi, my name is Sharifa binti Zaman. My metric number is DF210037. Now I will present about the analysis manual of our project. First of all, based on the practice design that we use, we must know whether the design is statically determinate or statically indeterminate. After doing the calculation, we found that the design we used was statically determinate and also stable with 3 reaction force. Then we put the vertical load of 3.92 kN downward at point B, D, E, and F because this is a bridge and each point will be subjected to a load from the vessel. Before we calculate the real force, we must know the value for each reaction that we use, which is pin and roller. So to determine the real force in each member, we use the alternative method. These forces are caused only by the real loads acting on the truss. After that, we can find the virtual force in each member. So to find it, we put the vertical load of 1 kN downward at point D and all real load is removed from the truss. Then the calculation to identify the value of reaction and internal force is the same as the calculation of real force. After get all the result from the real force and virtual force, we can identify deflection of the truss. Based on the direction of the internal force, we can also identify whether the joint is in compression or tension. If the direction is in compression, then the value is negative, while if the direction is tension, then the value is positive. In addition, the length of each member also needs to be placed in the table because the formula to calculate deflection is the sum of N and L per AE. So by using this formula, we get the value of vertical deflection at joint D is 141.65 kN square meter per AE downward.
Assalamualaikum and hi, my name is Nur Husnina binti Nisa. My matrix number TF210070. In this project, to analyze the bridge using the software, we have choose to use Limpro software. And I will explain how to use this software. First, you need to create a joint. The length of this bridge is 10 meter and the height for this bridge is 3 meter. After that, you need to create a member to each joint. Next, you need to release the moment of each member. In this part, you need to do it in trial and error to release the moment. Next, we will add the pin support at the joint 0 and roller support at the joint 6. After that, we will apply the load onto the bridge. After we apply the load, we will run the analysis to see the result. So this is the result from the analysis. This shows the moment diagram of our bridge, the shear force diagram, the axial force diagram, the deflection of our bridge, and also the reaction of our bridge.
Next, in the discussion part, from the calculation, it can be analysed that the bridge is stable and statically determinate using the degree of determinacy formula. Hence, the bridge is safe and possible to be constructed, and the both method of calculation, which is manual and LIMPRO software, get the outcome value for internal members with the same value. Next, by using the LIMPRO software, value of vertical deflection for the bridge is negative 0.000003 mm, which is the downward deformation. And from the value of vertical deflection, it can be assumed that the bridge specification is stable, as the result from the calculation is in small value. So some of improvement that can be made for this bridge is we can strengthen the bridge by thicker the truss section, reduce the span of bridge, and increase the number of support. We also can coat the bridge from rusting, such as using the galvanizing process with zinc metal to the steel.
Next is recommendation. So the first recommendation is about beam. So on a bridge, we know the structural component that resists loads applied to it exists is called a beam. So typically, beam is respond to force by bending in reaction to its support points. So proving the importance of a strong beam as the main support of bridge construction. There are three types of material that we use to beam, which is steel, concrete, and wood. So in this case, due to the location that we choose, the bridge is in a railway bridge. So we recommend the base for this bridge is being used concrete. So to be specifically is reinforced concrete. So although the steel we know very strong, but the characteristic of steel being high maintenance will force more manpower to be used for the regular painting and to attach it. So being exposed to air, the second reason is steel will be exposed to air and water and will not be beneficially for the construction. So the base of the reinforced concrete is the formation of a combination in different properties of concrete and steel. So this combination can produce a force to withstand compression and tension. So beside this combination, we'll cover the downside of the both material in order to produce a better and stronger beam rather than just one element. So the second recommendation is about column. So a column is a vertical support that is used to hold up a bridge. It can be made by wood, steel, and also a concrete. And a column is hammered into the soil beneath the bridge until the end of it reaches the hard layer of compacted soil or rock below. So column hammered to this depth leverage the grip and friction of the soil surrounding it to support part of the load of the bridge. Being column joints represent very important element of reinforced concrete structure. So the railway bridge needs strong elements or strong columns as support. So our recommendation is using a T-shaped column, it has a high strength and good seismic performance. So these shapes offer the significant flexural capacity on the flange side compared to non-flange side. So unlike the L shape, so the T shape offer high axial flexural capacity due to web depth and symmetry. So proving how beneficial this particular shape is the bridge for this construction. Next is conclusion. So after we finish this assignment or this project, we learn more about the many potential loads and how to combine load most effectively and how to figure out the various size of the beams and column in a straightforward bridge design. So this project helped us as a student in the structural analysis course to understand the output that come from the application that we use to settle this assignment or this project, which is LIMPRO or STEPRO. So by understanding this concept of this project, student can gain knowledge on how to determine whether the bridge is stable or not. And they can also determine the internal forces and other forces that are available in the model in the fastest and easiest way by using this application. So we also acknowledge that the bridge are one of the construction that contributes significantly to society by serving a link or being a connector between two otherwise remote regions. So they were a crucial part of the road and cities which is provide good support for people's daily life. So despite our choice of medium bridge, the bridge still also can be used or still support transport as they traverse the disconnected part, and we still able to complete the design based on the bridge.